Okay, we're going to talk about section 6.5, which is special parallelograms. And I went ahead and introduced those to you yesterday when we talked about parallelograms in general. But if you take a parallelogram and give it a special property, it becomes one of these three special parallelograms. So the first one you know is called a rectangle. And a rectangle is a quadrilateral with four right angles. Right, so angle J is a right angle, angle K is a right angle, L is a right angle, and I is a right angle. Now because it's a parallelogram, it still has all of the other parallelogram properties like opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. But it turns out that the rectangle has an additional diagonal property. So I'm going to show it to you. So here I've constructed a rectangle, and I can make it any size rectangle I want, but this will always be a rectangle no matter what I do to it. So what I'm going to do is put in the diagonals, and then next I'm going to go ahead and measure the diagonals. So I'm going to measure that right there, and so I'm going to add his length, and that one is 7.99, and I'm going to measure this length. That one is also 7.99, and it's not a coincidence. If I change the size of my rectangle, you'll notice that the lengths of the two diagonals stay the same. So that is the additional property for rectangles. Diagonals are congruent.
What?
Quiet, please. Okay, and then next is the rhombus. So a rhombus is frequently called a diamond, but the true definition of a rhombus is a quadrilateral with four congruent sides. So in this picture over here, NM, same length as NP, same length as PO, same length as MO. And that's what makes a parallelogram a rhombus. This is a special parallelogram, so it still has all the properties of a parallelogram, like opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other.
What are you doing?
Now, as you would probably guess, the diagonals of a rhombus are not congruent, if you can tell that MP is a lot shorter than NO. But the rhombus does have some of its own diagonal properties. So let's take a look at that. I'm not going to be able to construct one right now, so I'll just tell you what those properties are. You might have noticed already that these diagonals are actually forming a right angle. So the diagonals of a rhombus are perpendicular to each other. Okay, so that is the first property. So I say the diagonals.
I see triangles.
Yes, those are triangles. Very good. Diagonals are perpendicular.
Why? Why?
Okay. I'm going to stop the video for obvious reasons right now and pick up in the next video with the rest of the notes.